This will be a very brief video, and we're looking at how logarithms are involved with integrals. Well, we already know that if you have the derivative, if you're taking the derivative with respect to x of the natural log of u, or even the natural log of the absolute value of u, that equals u prime over u. Or we could say it's 1 over u times du dx. 1 over u times u prime. Well, we're going to work backwards. So what we're going to start with is the integral of a 1 over u du. Working backwards, we know that that is the natural log of the absolute value of your u plus c. And we need to keep the absolute values on here because you can only take the natural log of something positive. So the only time you'll take the absolute value off is, let's say you're doing the natural log of x squared. Well, x squared is always positive, so I don't need the absolute values on it. But otherwise, if it's just of an x, we need to actually make sure that we're putting something positive into the natural log plus c. So these problems are going to have division in them. You'll see a fraction bar usually. Okay, so that's step one. Now remember, there is no quotient rule for integrals. The quotient rule is for derivatives. So we are undoing a fraction, and we're going to use natural logs to do it. Second thing to notice, you'll do this when the power on the bottom is higher than the power on the top. Remember, it's u prime over u, the derivative over the original. This should have the smaller power. Okay. In terms of trig functions, what you're looking for is something that's a derivative of something else, not the power necessarily, but the derivative. I know the derivative of tangent x is secant squared x, so I have a u prime over u over here. So those are things to look for. Now, it's not to say the power on the bottom always has to be smaller, because if you actually start with something that, if you graphed it, it looked like a slant asymptote, where let's say you have an x cubed over an x squared, you could use long division, rewrite the problem, and then you'll be doing the logarithm to actually integrate the fractional part. So that's something to try out. For this one, these are u substitution. And because the higher power is on the bottom, I'm going to choose that as my u. So u equals x cubed minus 6x. So my du will equal a 3x squared minus 6 dx. So this is my u piece. So this is the integral of a 1 over u. And then I still have a 6x squared minus 12 dx. If I compare these, this one is just double that one. So this is equal to 2 du. So I can put the 2 here, or I can actually even bring it outside the integral. It's the integral of 2 times 1 over u du. So my final answer will be 2 natural log absolute value of my u, x cubed minus 6x plus c. And that's finished. If I do this again for this problem, I'm choosing the higher power. And again, if u substitution doesn't work, then it's not a u sub problem. These are set up for u substitution. Okay, but there are other methods for integrating. So u equals 5x squared plus 10. So my du equals 10x dx. But I have a 20x dx, so I need to double this. So this will be 2 times the integral of 1 over u du. So this one is 2 natural log absolute value of 5x squared plus 10 plus c. Now this one doesn't need the absolute value, because if I plug a negative number in for x, 5x squared plus 10 will be positive. If I plug in a 0, it's still positive. If I plug in a positive number, it stays positive. So it's fine like it is, or you could just have parentheses instead of the absolute value. Looking at this next problem, I have u equals 2x squared plus 6. So my du equals 4x dx. But I have a 5x dx. So I'm going to divide by the 4 to get rid of the 4. And multiply by the 5. So this is a 5/4. So this will be 5/4 the integral of 1 over u du. So my final answer will be 5/4 the natural log, the absolute value, and then you check, do you need absolute value in this one? And you don't. It's squared, that's always positive, times 2 is always positive, plus 6, always positive. So you could have the absolute value if you want, but you do not need it. Plus c. Okay, now trig functions. You're going to try the denominator, honestly. That's what you try when you have a fraction, but you're also looking to see, do I have a derivative over an original function? And yes, the derivative of tangent is secant squared. So this is, for this problem, u equals tangent x plus 1, and my du will equal secant squared x. The derivative of 1 is 0, so dx. And then this matches exactly. So this is just a 1 over u du. So my final answer will be the natural log, the absolute value of tangent x plus 1 plus c. And that is it.